Hello and welcome. Thanks for joining this webinar on the blockchain channel on Brighttalk. Today we're going to be talking about cryptoeconomics. We'll cover some of the basics. What is it? Why does it matter? And how can it be applied in the blockchain ecosystem? I'm Cathy Barrera, founding economist at Prysm Group. We're a blockchain economics and governance design firm. I have a PhD in business economics from Harvard, and I was previously faculty at the Johnson Graduate School of Management at Cornell. We at Prysm Group are PhD-trained economists using our expertise to help blockchain projects with their market, incentive, and governance design. So we're applying these cryptoeconomic tools every day. Cryptoeconomics brings together the fields of economics, computer science, to study the decentralized marketplaces and applications that can be built by combining cryptography with economic incentives. Today, we're going to focus on the economics part of cryptoeconomics. We're not going to get into a super technical level on the computer science side of things. Instead, we'll take sort of a high-level point of view on the cryptography aspect of cryptoeconomics. So let's get started. Today, we are going to cover a few topics. What is economics? Why is it important for blockchain? What is the first principles approach to economic design? And why is blockchain different from traditional platforms? I'm going to be stopping periodically to take some questions during the presentation. This is a bit of technical information, so I want to make sure everyone's following along. The first stop that I'm going to make will be after we talk about why economics is important for blockchain, and then I'll stop again after each section after that. So I look forward to taking your questions. So what is economics? You've probably taken economics classes where you solved a bunch of algebra, and that was supposed to tell you how people were going to behave. Over the past few decades, economists have increasingly explored how our tools can be used to design economic systems. Those are systems where there are many individuals and each one is independently making choices that best suit themselves. Economists have worked to design those systems with the goal of producing better outcomes. So one major example of this is market design, which Al Roth and Lloyd Shapley won the Nobel Prize for in 2012. Market design has been used to improve outcomes in contexts as wide-ranging as auctions for telecommunication spectrums, like radio channels or 4G transmission blocks. It's also been used for elementary school assignment in large cities like New York, where some schools are very competitive to get into. And it's been used to help match kidney donors with recipients. In addition to market design, there's a bunch of economic fields that contribute to this sort of economic design. So things like social choice, contract theory, and international economics have all been used to design economic systems. Now, similar tools are being used to help with the design of blockchain systems. So, for example, these tools have been used to improve the functioning of decentralized token exchanges. And they can also be used to aid in the design of a variety of other contexts within the blockchain ecosystem. Before we get into a more detailed discussion of how economics applies to blockchain, I think no Cryptoeconomics 101 course would be complete without a little taste of Economics 101. So you may be familiar with the prisoner's dilemma game. It's often taught in introductory to microeconomics courses. I'm not going to go into too much detail here about exactly how this game works. You can Google it and learn more about it. But I just want to give a broad overview. So the gist here is that there are two individuals and they face time for having committed a crime together. Each one is being offered leniency by the police if they confess on the other one. But the police don't have enough evidence to be able to convict either of them of the crime they committed if neither one of them confesses. Instead, the police are only going to be able to get them for a relatively smaller crime if neither of them confesses. So the reason that this game is so interesting, the reason it gets so much attention, is that the results of the game are counterintuitive. The prisoners will be able to get a much lighter jail sentence if they both keep their mouths shut. That's that upper left-hand corner, -1, -1, like 1 year in jail. But each of the prisoners is actually going to prefer to confess no matter what the other one is doing. So even more astoundingly, both confessing actually leads to a worse outcome for each of them than if they were both to just stay quiet. So that's that lower right-hand quadrant, -2, -2. More jail time if they both confess. Situations like the prisoner's dilemma appear often in things like TV shows, movies, and books. And we as onlookers wish that the characters could just manage to make decisions that would lead them to these better outcomes, that upper left-hand quadrant. But in order to accomplish that, they would need some sort of mechanism that would help bound them to staying quiet, right? So instead, because each one is making an independent decision, and because there's no person or mechanism that's going to enforce their mutual silence, the design of the system creates a situation where they're unable to reach that better upper left-hand outcome. Instead, they're going to be stuck in the lower right-hand corner. So why is economics important to blockchain? Well, blockchain technologists and entrepreneurs are essentially building mini economies or economic systems, which, as we talked about before, economic systems are systems where many individuals are independently making choices that best suit themselves. So whether they intend to or not, founding teams influence the behavior of future users and the likely outcomes of their platforms when they make choices about how their platform is going to work. Blockchain platforms are essentially economic systems that have been enshrined into code. So there's one technical caveat here. Economic systems, blockchain are economic systems enshrined in code is particularly true for open or permissionless blockchain systems. It can also be true for some permissioned systems, depending on exactly who controls the nodes of the network. For the purpose of this webinar, we're going to focus on those open and permissionless systems. So ones in which the rules of the game are the only thing that is allowing the individuals who are participating to coordinate. Just focus on, again, those open systems for the purpose of this talk. A blockchain platform is not going to achieve the goals that its founding team has envisioned if the system itself is not designed well. So the design of these systems should employ economic tools, ones that have been developed in the field of economics over the last many decades, because it's quite easy actually for things to go wrong, for unintended consequences to happen if these systems aren't designed well. Economic tools can be applied to 3 levels of the blockchain ecosystem: the protocol level, the app level, and the ecosystem level. For the bulk of this talk, we're going to focus on the first 2 of those, the protocol level and the app level. At the protocol level, economic design can encourage miners to participate in the production of the blockchain, and it can discourage bad actors from attacking the blockchain. So let's look at an example here. We'll look at Bitcoin. So Satoshi Nakamoto, the individual or group, unknown group, who developed the Bitcoin protocol, envisioned a cash-like system in which powerful entities wouldn't be able to exert control. The system needed to garner users, but more importantly, it needed to attract miners who would then maintain the blockchain itself. Finally, they needed to design the system so that even though no one controls it and anyone can participate in its maintenance, that the system is still going to be secure. Proof of work is the consensus protocol, the software that underlies the Bitcoin blockchain and rewards a miner each time they produce a new block with new Bitcoin. Currently, the block reward is 12.5 Bitcoin, and that halves about every 4 years. So these rewards have succeeded in attracting many individuals and groups to participate in the production of the blockchain. And it's even led to investment in specialized equipment just for the purpose of producing more blocks. The protocol is also designed to make attackers think twice before trying to subvert the system, and it has successfully defended the system from attack. The security design of the Bitcoin blockchain involves making it very expensive to attack it. Producing blocks requires a lot of computing power, and it's quite costly to produce those blocks. But more importantly, it would require 51% of all of the computing power in the network to be able to cheat the system. And moreover, the computing power required to produce the next block is going to increase when there's more computing power in the network. So that means it's going to be just extremely costly to launch an attack on this system. And it's that set of economic incentives that keeps the Bitcoin blockchain secure. So while having a secure system is incredibly important, this specific design for the Bitcoin blockchain has resulted in a couple of undesirable outcomes. First, that fierce competition for block rewards combined with the development of specialized equipment that I mentioned has led to a consolidation in the market for miners and the development of mining pools. And this means that just a few mining pools contribute most of the blocks to the blockchain. So given this consolidation up to this point, it seems that Bitcoin hasn't exactly lived up to Satoshi Nakamoto's vision of having a system with distributed power. In addition, the Bitcoin blockchain is extremely expensive to maintain due to the quantity of energy that's required to produce those blocks. So not only is this a problem environmentally, but it also limits the number of users and use cases for which Bitcoin would be an ideal means of conducting transactions. So while there are a lot of advantages to Bitcoin's design, there are also ways in which the design could be improved if the goals of the system involved, say, distributing market power more or achieving mass adoption. So we've looked at how economics can be applied at the protocol level. Similar economic design principles can be applied at the app level or the dApp level. Here, economic design can encourage users to contribute high quality content, services, or goods, and it can also encourage them not to cheat other users in peer-to-peer interactions. Let's look at an example of that. At Prysm, we get many requests for help from teams who are creating token curated registries. A token curated registry is a list. For example, say a list of the best restaurants in New York, or of the best colleges in the United States, or even the best tokens to invest in. That list is curated by a decentralized group of token holders. In a similar spirit to Bitcoin, one of the goals of token-curated registries is to remove or redistribute power from an individual or small group of entities to a larger open group. And that's in order to reduce the risk of problems like bribery or censorship. Of course, that goal coexists with the goal of producing high-quality content that the readers of the list will find useful. As my partner, Dr. Stephanie Herder, wrote in a recent blog post, there are some potential pitfalls to designing a token-curated registry. Like in a prisoner's dilemma game, it's possible for a token-curated registry to have a bad outcome. So even if it seems obvious to all of us that the token holders should want to fill their registry with high-quality content, it's possible that the equilibrium outcome of this game is for them to fill it with spammy content that doesn't live up to the spirit of what the founding team envisioned. You can read our blog post. It's called Nash Equilibrium and Blockchain Platforms. It's on our blog, the Prysm Group blog on Medium. After we wrote this post, we were actually contacted by a team who had a token-curated registry. I'm going to call them Token Curated Registry X to protect their identity. But basically, they told us that their registry is in the bad equilibrium. The token holders are kicking out good candidates, kicking them off the registry, while letting bad candidates onto the registry. And even worse, the founding team isn't able to do anything about it because it's a decentralized system that's now in the hands of the community of token holders. Okay, so we've covered a lot of ground so far. I know it's a lot. We talked about what is economics. We really quickly went over the prisoner's dilemma game. And then we talked about why economics is important for blockchain. I think it could be helpful to just stop for 5 minutes and take some questions about the material we've covered so far. So I have a question here. Will the slides be made available? Yes, the slides have been uploaded, and I'll make sure that they are accessible to you all after the presentation. Do we have any questions about the content? Okay, well, please feel free to go ahead and post your questions if you have any as we're moving forward. And yes, I can absolutely explain how blockchain and Bitcoin are related. So blockchain is what we call a distributed ledger. It's just a system of record keeping that in the context of a cryptocurrency like Bitcoin is used to keep track of transactions. So Bitcoin is a cryptocurrency that people can use to pay each other or make trades. And the blockchain is the underlying record of all of the transactions that have been conducted using Bitcoin as a currency. We have another question about token-curated registries. If token-curated registries can be scammed so relatively easily, why should we use them? So I think this is a bit of a complicated question. So certainly I think we should think carefully about which context we should use a token-curated registry in. The idea that we could use a decentralized system to create a curated list is beneficial because we would like to ensure that the list is put together in a straightforward way that is not controlled by special interests. So we want to make sure that the creators of the list haven't been bribed to include content that maybe isn't as of high quality as we'd like, or that they aren't censoring good content that should be included. And the idea is that by decentralizing that system, instead of letting one entity control it, like the New York Times controlling the list of best books, or a restaurant guide controlling the list of best restaurants, by opening that up and making it a democratic process, you could potentially avoid some of these pitfalls like censorship or bribery. So in a context where it's really important to avoid those problems, you may want to implement something like a token curated registry. On the other hand, of course, there are these potential problems where if it hasn't been designed well, then you can sort of end up with this spammy content. So the important thing is to design all of the components of the registry so that it works well and achieves its goals. So I have another question here. Can you please, again, explain the difference between a protocol and the dApp for cryptoeconomics? So the protocol is the set of software that controls the blockchain itself. So those are the rules that tell us how blocks can be contributed to the chain, how new records can be added to that ledger. And it helps to secure the system so that while many people can contribute and maintain the ledger, that it's still secure so that the record keeping can't be cheated. That's the protocol level. On top of that, you can have the app level. So this is where we are going to use the protocol, the blockchain, to keep track of transactions and activities that happen, but the app itself is going to tell us sort of what those activities are. So the token curated registry example, we are going to vote content into the registry or keep content off of the registry. Those votes, those interactions between users will be recorded into the blockchain, but there will be a smart app or a smart contract that will determine how the interactions of the users result in an outcome that's then recorded onto the protocol. Okay, thanks for all of the great questions. We want to make sure we get through all of the content. So I'm going to continue now, but we'll return to questions a little bit later in the presentation. So how can we use economics to design better blockchain platforms in order to reduce some of these undesirable outcomes that we talked about? Good economic design employs a first principles approach. So while it's very easy to get excited about a new technology or an innovation and to want to apply that innovation in your context, for economic design, it's very important to take a step back and start from the beginning. So what problem are you solving? Only after you've answered that question should you start to think about what technologies or methods you're going to use. That's the second question. How should you solve this problem? At Prysm, all of our client solutions are custom designed from the ground up. It's important to start from the beginning instead of trying to plug and play when it comes to economic design, in part because each solution is going to depend on the context and the specific goals of the founding team. For example, as we discussed with Bitcoin, there are a variety of goals that a cryptocurrency could have. Distributed power, airtight security, and mass adoption are just a few of those. Now, these goals will often be in conflict with one another. So you're going to have to make trade-offs. It's up to the founding team to decide what it is they hope the system will accomplish and what they're willing to sacrifice in order to maximize some of these objectives. The design should be customized according to that team's specific goals. And relatedly, the mechanisms of economic design don't really copy-paste well. So Bitcoin appears to function really well as a store of value. But if one wanted to create a cryptocurrency that acted more like a medium of exchange, then just replicating the Bitcoin protocol wouldn't accomplish that goal. So the design has to be purpose-built for the specific context in which it's being used. It's also important for the design of the system to start from the ground up, because each system is going to have a variety of pieces that are required in order to make it work. For example, a token curated registry is going to need a voting system, and that's going to include rules about how many votes each voter gets, what are the voting thresholds required for accepting a candidate entry onto the registry, and how much do each of the parties have to pay to participate, and how much do they get rewarded for contributing. Now, in addition to these voting rules, the token curated registry is also going to need an information system in order to ensure that the voters can adequately assess the quality of candidate entries. All of these pieces of the system are interdependent. So the best voting scheme is going to depend on the information system available, and the best information system is going to depend on who the likely voters are. And the likely voters will depend on the costs and rewards that the system enables. So the platform has to have a unified design that works cohesively together toward good outcomes. Starting from a first principles approach means building your economic system from the ground up. As we just discussed, it's important to design economic systems this way for 3 reasons. 1, each founding team is going to have its own set of goals for what the system should do. So the design should be custom according to those goals. 2, the design needs to fit the specific context in which it's used, so it has to be custom to that context. And 3, the parts of the system need to work cohesively together. So with the token curated registry example, the design of the voting system and the information system should each be designed together to work cohesively. So I know this is a lot of information. Thanks for sticking with me. Let's open it back up for questions. So I have a question here. How does a participant vote in the token curated registry process? Are the number of votes dictated by the number of tokens owned? This is a great question. So in most token curated registries, the number of votes is related to the number of tokens owned. Usually it has to do with the number of tokens you have staked or sort of put in an escrow account. Now, exactly how that relationship works between the number of votes you get and the number of tokens you have is an element of the design. So you as a platform designer can choose what that relationship is going to look like. I have a question here about, is it possible to change the economic design after starting operations? Does the blockchain allow it? So we're going to talk about that a little bit later in this same presentation. I have a question about how does the prisoner's dilemma apply to blockchain economic systems? So I used the prisoner's dilemma at the beginning of the presentation because it's a super simple example. It's usually one of the first things that you might learn in a microeconomics course. And the idea here is that it demonstrates what happens when you have a decentralized system where each individual is making choices that best suit themselves. And in this example, you end up with a bad outcome because the participants aren't able to coordinate on a better outcome. They have no mechanism to bind them to staying silent. So I think that this example, this prisoner's dilemma game, is applied to blockchain economics because blockchain systems are decentralized economic systems where you can try to build the coordination mechanisms to help the participants get to a better outcome. If those systems aren't designed well, then it's going to be difficult for those participants to coordinate. I have a question here. Can just anybody design a blockchain? I think this is a great question. So you really do need quite a bit of expertise on two sides of this problem. As we talked about, cryptoeconomics is a combination of economics and computer science. So you definitely need a lot of technical skills on the computer science side. There's a relatively small number of people at this point who are experts in the software design or the development languages that are used to produce blockchains. On the other side of the coin is the economic design. I think this is super important for all blockchain teams to have, whether it's an internal skill that you have on your team or it's help that you get from the outside. I think that anyone can probably come up with a great idea for an application of blockchain. The trick is going to be to building a team that has all of the required skills so that you can execute that idea well. Great, thanks for your questions. We're gonna keep moving and I will take more questions a little bit later on in the presentation. How is blockchain different from the economy outside of blockchain, or how is it different from traditional platforms? This is a question that we get a lot. It's asking, why is cryptoeconomics special? The answer is that distributed systems are especially challenging. As I mentioned before, whether they intend to or not, blockchain developers are designing economic systems which will influence the behavior of future users. So unlike some open marketplaces, these systems are designed. The question is whether they'll be designed well. It's impossible for those who are writing the code of a system to not make choices that will impact how future users will behave and what the outcomes of the system will be. It's important for those choices to be made in a way that furthers the goals of the platform. So it's crucial for whoever is developing or designing the platform to have an understanding regarding how their choices will impact those eventual outcomes. That's where cryptoeconomics comes into play. In addition, as we discussed with reference to Bitcoin and token curated registries, blockchain protocols are decentralized apps that are intended to be systems lacking a clear central authority. Whereas a company that owns a traditional platform can choose to remove users that are behaving badly, that's not an option for developers of decentralized systems. So, for example, platforms like YouTube or Facebook can eject users who violate their terms of service. Ones like Token Curated Registry X can't do that. In decentralized platforms, developers are creating an economic system where the rules that govern the system are enshrined in code. They have to design those rules so that the system itself enforces the desired behavior. The threat of removal like that on YouTube or Facebook has to be replaced by some type of incentive mechanism that will encourage the outcomes the founding team wants. This is a much more complicated proposition than creating a centralized platform where you can use authority to correct bad behavior. Decentralized systems pose an additional challenge in terms of how they can adapt over time. So this goes to the question from the audience member. Traditional companies and other organizations utilize authority or decision rights to be able to correct a mistake when something isn't working or to simply improve upon the system. This isn't possible in a distributed system because that authority is absent. So alternatives to authority have to be developed that will allow these systems to change over time. For example, the Bitcoin community has struggled with how to adapt its system in order to allow for more transaction throughput. Different community members have different views regarding how this issue should be addressed. And progress is slow because there's no clear decision maker or decision-making process. Satoshi Nakamoto did not design a governance system for Bitcoin. So many platforms have sort of seen that this is a problem and are now developing governance systems to provide a decision-making process that will aid adaptation. The aim is to get a distributed set of voters to make independent choices that will further the objectives of the platform. So these governance systems are also economic systems that will benefit from good design. This leads us to our third and final level of cryptoeconomic analysis, the ecosystem level. Blockchain is a technology that reduces market power and the control of authority. This means that it could be difficult for a controlling entity or a company to profit from an application of blockchain technology, depending on how that application is implemented. For a truly decentralized or disintermediated system, those investing in it have to receive their return on investment in a different way than traditional equity. So innovations and funding mechanisms have to be developed. The ICO is one of those innovations. But blockchain technology is still in its relatively early days, and innovations are going to continue to be developed over time. From an economics perspective, ensuring the funding of valuable and useful innovation is of vital importance. Cryptoeconomics can provide insights that help ensure the funding of these decentralized platforms. Blockchain technology is different because it facilitates decentralized systems. There are important economic implications for decentralization or the elimination of centralized authority. So as we just discussed, on decentralized platforms, authority has to be replaced by some sort of incentives or other mechanism that will facilitate the day-to-day running of the platform. In addition, that authority has to be replaced by a governance system in order to facilitate the long-run maintenance of the platform or the way that it adapts and changes over time. Truly decentralized systems are going to require innovation in funding mechanisms, like the ICO. So we've covered what is economics, why is economics important for blockchain, what the first principles approach to economic design is, and why blockchain is different from traditional platforms. Let's take another short break for a Q&A. I have a question. Can we have some examples of protocols that have consensus or governance systems? So all protocols have some sort of consensus algorithm. That consensus algorithm is specifically the software that helps maintain the blockchain itself. In terms of governance systems, one really famous example that's trying to institute governance is called Tezos. It's T-E-Z-O-S. And they have a relatively innovative system that would be worth taking a look at if you're interested in those issues. So I have a question here that it says, so I'm just going to read the first part of this longer question. For supply chain, is proof of authority consensus more economic and a preferred choice? I think this is a great question. So this highlights what I talked about toward the beginning of the presentation, that design choices have trade-offs and therefore help different applications of the technology work better or worse depending on the application. Proof of authority is an alternative to proof of work mechanism, and it's a slightly more closed system than the proof of work system. So in proof of work, anyone can become a miner for the blockchain. Anyone can contribute to the blockchain's maintenance. And that creates a situation where it's extra hard to secure the network since anyone is allowed in. And that makes blockchains that run on proof of work, such as Bitcoin, very expensive to maintain and secure. One alternative to proof of work that has been used in other blockchains is proof of authority. This is what I would call a semi-permissioned system. So in proof of authority, you have new nodes can be voted into the system. So you can't just join automatically. Instead, the existing nodes have to give you permission to join the system. It's more decentralized than a completely permissioned network in which you only have one authority, one centralized authority deciding who can or cannot be nodes. And because each node is approved into the system, it's a little bit less costly to secure. So we trust these nodes because they've gone through the approval process. For that reason, this can be a more economically feasible consensus mechanism or blockchain algorithm for a variety of different applications. And I do think that supply chain management is one of those applications. Thanks for the great questions. So I'm just going to finish up the conclusion of the talk, and then I'll stick around to answer as many of these questions as we can with the remaining time. Blockchain technology has the potential to change the world. This is an innovation that enables the creation of new kinds of systems, particularly those that lack a centralized authority or market power. That was not possible with previous technologies. However, these new systems need to be designed carefully in order to achieve their lofty goals. Cryptoeconomics is the study of individual decision-making, so that's what each person is independently going to choose for him or herself, and strategic interaction, how the combination of all of those individual decisions will result in a platform-wide outcome in the context of cryptographically secured digital institutions. Those are the rules of the game that have been designed by the blockchain developers. Cryptoeconomic tools can facilitate good blockchain platform design. Today, we talked about why design is important for these systems, and we used some examples. At the protocol level, we talked about Bitcoin, and at the app level, we talked about token-curated registries. But decisions are happening, and economic design is having an impact at all levels of the blockchain ecosystem. At the protocol level, economic design has an impact not only on the contributions of the miners who maintain the blockchain, but also on how much power is exerted by those miners over the system and how costly the system is to run. And those both in turn have an influence on whether individual users or apps will want to adopt that blockchain. At the app level, the economic design can help ensure that users contribute resources like good judgment for token-curated registries, and to do that in a way that the founding team intended. At the ecosystem level, a variety of groups are working to improve the basic technology that is going to be used by many, many people, but that can be controlled by no one. This has an impact on the ability to fund the development of this breakthrough technology and its related innovations. Decentralized platforms, like those that utilize blockchain technology, are complex economic systems that require rigorous design because they lack authority. Without rigorous ground-up design, it's easy for a system to have undesirable outcomes. Remember the prisoner's dilemma game. Even when the developers of that system have good intentions, like the founding team of token-curated registry X found out the hard way. Cryptoeconomics builds on the methodological tools of economics and over a century of economic research in order to guide decentralized platforms and communities toward positive outcomes. In order to reach those outcomes, we need to use good economic design. So thank you so much for joining me today. With the remaining time, about 10 minutes, I'm going to try to answer as many of your questions as I can. So the first question I have here is, do you evaluate projects in South America? Answer is yes. We have team members all over the world, and we work with projects all over the world. I'll actually flip to, here's our contact information, so you can get in touch. You can find us at prysmgroup.io. You can shoot me an email at Cathy@prysmgroup.io, and you can find some of our blogs and other content on Medium and at our website. I have a question here. Would not voting in new nodes, I think that you're referring to the proof of authority system, would not voting in new nodes lead to a good old boy system? If you don't know anyone, how can you get voted in? Yes, I think that that is entirely possible. So again, these systems need to be designed very carefully with a lot of thought to avoid exactly this type of problem. So maybe that means that nodes are required to bring in a certain number of new entrants every so often. Maybe there is an application system that can account for this type of problem in order to try to avoid it. I have a question here. How do governance protocols differ from centralized regulation? Instead of YouTube, it's a few hundred people or entities involved in the governance. So each governance system is designed differently. Some governance systems are designed so that all users or token holders can vote on proposed policy changes. Some are designed so that only the node operators can have a say. So some proof of authority systems employ a governance system that looks like that. Again, each system is designed specifically to address the issues that might cause problems within that system. But the idea is that because these are distributed systems where you have a number of nodes who can be anyone or are able to join the system without getting permission from one single centralized entity like a YouTube, that the power is more distributed among a greater number of people than one single entity like YouTube. I have a question. Is an ICO a token curated system? I think the question here is asking whether an ICO is a token curated registry, and the answer to that is no. An ICO is a token sale, an initial coin offering. So that's the way that that new projects raise funding for the development of their platforms. The new tokens can be created for a number of different types of applications, not just for token curated registries. I have a question about what policy oversight is established from a government perspective, for example, the SEC. There are a number of regulatory bodies, including the SEC, who are currently carefully looking at the space. Right now, we have some ambiguity because the space isn't really regulated at the moment. These government bodies are still deciding what rules they're going to make and impose for these decentralized systems. And of course, that's a challenge because of some of the issues that we talked about today. But the SEC and other regulatory bodies will continue to follow their mandate. So for the SEC, that means that they need to protect potential investors while trying to facilitate the funding and development of new technologies. So that's definitely something to keep an eye on over the next, say, 6 months to 1 year. We should see some progress in that area. I have a question here. Do you know of anything in the works, or this could be used for something like electing public officials? I know that there are a number of countries who are looking into using blockchain to facilitate national elections because it's a transparent system that is difficult to attack or manipulate. So certainly there are applications being developed, and you can Google to find out more about exactly where in the world these systems are being developed. I have a question here. Are token curated registries accessible to the general public, or is it available only to cryptocurrency players? So there's two parts to this. The token curated registry, the list itself is typically accessible and viewable by any reader who would like to have that information. The voting system is accessible only to token holders. But for many of these systems, anyone can buy tokens and therefore participate in the curation of the system. I have a question here. Token curated registry does not prevent fraud or abuse. Does that mean the blockchain system, as all other systems, is dependent on the integrity of the users? I think that the answer to this question is yes and no. Of course, you want to have users with great integrity contributing to the system. And it's best if you can maybe keep out those bad actors. The interesting thing about designing these systems is that they can be created in a way where three things happen. You encourage those high quality users to participate. You make it unattractive to those bad actors to participate, so maybe they self-select out of the system. And then on the margin, you create incentives so that people in the middle participate, but they are more likely to contribute high quality participation than they would have without your system design. So the answer is, of course, in the world, there are people with high integrity and people who lack that integrity. And by designing these systems, we can try to reach better outcomes through selection and also through incentives. So we're just about out of time here. I want to thank everyone for joining today. If you have more questions, you can reach me at Cathy@prysmgroup.io. I encourage you to look at our blog. We are at medium.com/Prysmeconomics. I also post some content for the MIT Cryptoeconomics Lab on their blog at medium.com/MIT-Cryptoeconomics-Lab. If you're in the New York City area, I invite you to join us at our next event. We'll be talking about blockchain governance, challenges and opportunities for a decentralized system. I'll be speaking with Professor Oliver Hart from Harvard. He's the Nobel Prize winner from 2016. That event will be on Thursday, June 28th at the Harvard Club in New York City. You can use this coupon code BrightTalkVIP and find the invitation at the address below. Thanks so much, everyone.